Hello friends, today let us see about ionic equilibrium, and it's nothing but small short notes of it. And I am now going to say in this video about the introduction of ionic equilibrium and also just a small introduction to acids, bases and salts. And in the next part I am going to explain the Arrhenius theory. In the part 3 I will explain about the Bronsted-Lowry, and then in the fourth part I am going to explain the Lewis, and in the fifth part I am going to explain about the pH scale. Okay, now let's see about the introduction and also acid, bases and salts. Firstly, if you see, how did we get all this? First of all, Michael Faraday, he have conducted many experiments, and one of his experiment was that where he conducted electricity in substances of aqueous solutions. In that aqueous solutions, whatever conducted electricity through them, he called them as electrolytes, whereas that did not conduct, he called those as non-electrolytes. And if you see, for example, let's see about the electrolytes. Whenever sodium chloride, common salt, NaCl, it is added to water, and then electric current is passed through it, then the bulb glows. And as we increase the amount of NaCl being poured into it or added into it, then the intensity or glow of the bulb is even increased. And if you see non-electrolytes, for example, I added a bit of sugar in water and connected it to the circuit, and then the bulb does not glow, since this sugar can't break into ions, whereas sodium chloride, it has the ability to break into ions and conduct the electricity. So now let's see, in these electrolytes, what are the types of electrolytes? Electrolytes can be classified as strong electrolytes and also weak electrolytes. So first, how did he find out whether one is a strong electrolyte or else a weak electrolyte? Strong electrolyte is nothing but the electrolyte that dissolve and it even dissociate into ion completely just within a few seconds of time, just within a very minute period of time. And the rate of dissolution and dissociation into ions is very high in the case of strong electrolytes, where complete dissociation takes place, 100% dissociation. And in the case of weak electrolytes, the electrolytes that dissolve and dissociate in water, dissociate, that may be in anything, they dissociate into ions slowly, and their dissociation rate is very lower, and the percentage of dissociation of weak electrolytes, it is less than 5%, and we can take it as approximately 5%. For example of strong electrolyte example, we can take the same sodium chloride. And whereas in the case of weak electrolyte, I am taking now strong electrolytes, we can take as strong acids, strong bases, strong and even salts. Weak electrolytes, I am going to take weak acid or weak base. So I am taking the example of a weak acid, that is nothing but acetic acid, which is present mostly in vinegar, which is actually the main constituent of the vinegar. And that acetic acid, it conducts, but its rate of dissociation is very low, such that it just dissociates less than approximately equal to 5%. And even acid, bases and salts, they may even act as a strong or a weak electrolyte. So now acid, bases and salts, this classification was given by Robert Boyle, and Robert Boyle, he classified the substances into acids, bases and salts. What are the properties of acids? Let's see about the properties of acids. They may be sour, they are sour. How we can say that they are sour? Because of the taste, they have sour, and that's why the name was given to them from Latin as from the Latin word acidus, which meant that acid, which means that it was sour. So in now we are using it as acid, and the acids have the capacity to convert they have the capacity to convert the blue litmus into red, and liberation of hydrogen will take place whenever we add metals to it. And for example, let's see the examples of acids. And there, let's see HCl, hydrochloric acid. It is secreted by the lining of our stomach, right? Approximately 1.2 to 1.5 liters of hydrochloric acid is secreted by our stomach lining of our stomach for the purpose of digestion. And even vinegar, it has acetic acid. And even lemon and orange, they have citric and ascorbic acid. And tamarind has tartaric acid. And now let's go on to the bases. The bases, they have the ability to turn red litmus into blue, and they are soapy in nature, and they have a bitter taste. For example, sodium hydroxide and potassium hydroxide, etc. And even washing soda, it is used for washing purposes. Salts are nothing but whenever acids and bases, they are mixed exactly or in a proper proportions, then salt is produced. For example, barium sulfide. So barium sulfide, NaCl, sodium chloride, and also NaNO3, and even potassium chloride. So now let's see some of the salts. They are mainly, they are important in our daily life, and even for some of the sources. There are even some of the sources of iodine, etc. NaCl, it is very important component of our diet, where it will be helpful for increasing the blood pressure levels, and even keeping it into a normal level. And now the electrostatic forces between two charges, they are actually inversely proportional to the dielectric constant of the medium. Why are they inversely proportional? Means what? Of the medium, they said. For example, now I have taken the same sodium chloride and I have added it in water. The electrostatic forces, for example, these are the electrostatic forces. These four fingers are having electrostatic forces before adding in water. After added in water, they dissolve and dissociate, and then where are the electrostatic forces between them? So in such a way, the electrostatic forces are lower. It decreases as the solubility rate of that, the ability to make a substance to get dissolved in it, right? So water, it is being as the universal solvent, as it has the highest dielectric constant of 80. It means that it can dissolve a substance whenever added to it nearly to 80% immediately. And so it has more capacity to regulate electrostatic forces between two charges, and even it make it to get dissolved in it. And ionization of strong acid in water, if you see, 100% formation of ions we have seen before. Strong acid, strong base, strong electrolytes, right? So strong acid, it will dissolve or form ions completely 100%, whereas weak acid, it is less than 5% formation into ions. Thank you.